Zeros, roots, x-intercepts, and solutions. Consider the function f of x equals ax squared plus bx plus c and a number s. If f of s equals 0, the following statements are true. S is a 0 or root of the function f of x equals s is a solution of the equation f of x equals 0, s, 0 is an x-intercept of the graph of f of x. Note 1. A 0 or a root is a number that corresponds to the x-coordinate of an x-intercept. A 0 is not a point in the plane. Note 2. Functions have zeros, roots, and x-intercepts. Equations have solutions. A quadratic function can have no zeros, 1 0, or 2 zeros. The graph of f here has no x-intercepts. It doesn't ever cross over the x-axis. That implies that this graph of x squared plus 2x plus 2 has no zeros, and that the equation x squared plus 2x plus 2 equals 0 has no solutions. There's nothing you can put in for x that will cause this to equal 0. A quadratic function can have no zeros, 1 0, or 2 zeros. Here we have the graph of x squared plus 2x plus 1. It has exactly one x-intercept right here at -1, 0. And so that shows that the function g of x equals x squared plus 2x plus 1 has 1 0. And that the equation x squared plus 2x plus 1 equals 0 has exactly one solution. So we factor this to x plus 1 times x plus 1, and so x equals -1, if you plug that in here, would make both of these terms 0. So that is the only solution is x equals -1. And this has 1 0. A quadratic function can have no zeros, 1 0, or 2 zeros. Here is the graph of the function h of x equals x squared plus 2x. And we see that it has 2 zeros. It dips below the x-axis and then comes back up. So it intersects here and here. The equation, therefore, x squared plus 2x equals 0, has exactly two solutions. If we factor out this x, we can see that x equals 0 or x equals -2 here would cause this to equal 0. So there's two solutions.